Hey everyone, today we're going to be going over the USA Computing Olympiad 2023 December contest, Bronze Division, problem number 2, Cowntact Tracing 2. Okay, so let's quickly read the problem. So, Farmer John has N cows in a line. Unfortunately, there is a sickness spreading throughout. Initially, some cows start off infected. Every night, an infected cow spreads the sickness to the cows on their left and right, if that is, if they exist. Once a cow is infected, she stays infected, right? So after some amount of nights, Farmer John realizes that the issue has gotten out of control, so he tests his cows to determine who has the sickness, find the minimum number of cows that could have started with the sickness. So in our input format, so it's going to be standard input. The first line contains N, the number of cows that Farmer John has. The next line contains an N character bit string of only ones and zeros, where a 1 represents an infected cow and a 0 represents an uninfected cow after some number of nights. And the output format, right? So this is again std out, standard output. We're going to output a single integer, the minimum number of cows that could have started with the sickness. So in this case, we're given a sample input. So the first line is 5, which means that we have 5 cows in our bit stream. So 1, 2, 3, 4, 5, right? And all of the cows have been infected. So we want to output the minimum number of cows that could have started this infection. And in this case, it's just 1, right? Because if we put 1 cow in the middle, right here, right? At 0 nights, it's this state, right? And then on the first night, it's going to spread the sickness to the left and the right. So we have 3 cows in total infected. And then 2 nights, all the cows have been infected. And that's exactly what we want, right? So there you go. And then, I mean, 1 cow is sufficient, but you could obviously have other more cows, right, that could have created the same state, but that's not what we want to output, right? We want to output the minimum number of cows. But just for a demonstration of how the mechanics of this problem works, let's take a look at this, right? So at 0 nights, we have a cow at the left edge and the right edge, right? Now notice that it's only going to expand to the left or the right if a cow exists there. So in this case, this cow, right, on the first night, it's only going to expand to the right, and then the cow on the right edge, it's only going to expand to the left, right? No more space on the right. And then finally, from this state, at 1 night, we get to all of the cows have been infected at 2 nights, because this cow is going to infect the cow to the right, right? This cow is going to infect the cow to the left, right? So in the end, the middle cow is infected, and then now we have all cows being infected, right? And so you can look through the other examples of how infection works over time, right? And in this last sample case, right, so we have 6 cows in our bit stream, 1, 2, 3, 4, 5, 6. And we have how many cows do we need to create this state initially? That's going to be 4, right? We need all of these cows, right? 3 cows here, 1 cow here, right? And, you know, the reason for that is if we have to create any interval, right? By interval, I mean an infected window of cows, we need at least 1 cow, right? That's just common sense, right? And in this case, to create this last window, we have to have 1 cow, of course, right? But the thing is, to create this window, right, we can't just use 1 cow, because after 1 night, right, this cow is going to infect that cow to the left, and it's going to create an interval that exceeds the interval that we want, right? So the only way we can create this interval of 3 cows while preserving this 1 interval in our end state is if we have all 3 cows at once, right? Okay. So let's think about how we can solve this problem, right? And we can make a few observations right off the bat, which is that the minimum number of cows required to create these sets of infected cows, and I'm terming those intervals, right? So in this case, right, we have 2 intervals, an interval of 3 cows and an interval of 1 cow, right? That is going to correspond to the maximum number of days to create the intervals. We can just derive this based off our intuition, right? Because the more days it takes, right, the smaller number of cows we need, okay? So essentially, if we figure out the max number of days to create the intervals, then if we are able to figure out a formula in which, given an arbitrary interval length, let's call it L, and the number of days it took to create that interval, we'll call it D, we have solved the problem, right? Okay. So essentially we can break this problem down into two steps, right? The first is we want to figure out the maximum number of days to create the intervals, and then to figure out the formula, right? So what do we want? We want some sort of function that's going to take initial number of cows, right? We're going to take in the interval length L and D, and what we're going to output? We're going to output max number. We're going to output the minimum number of the initial number of cows, right? Okay. Initial number of cows, taking in the interval length L, number of days to create the interval D. Yep, that's what we want, okay? So first things first, let's tackle step one, right? Now, let's create another observation, which is this, right? The maximum number of days to create all the intervals is going to be the maximum number of days to create the smallest interval, right? We'll call that I sub min, okay? Interval, minimum interval, okay? And this is because if we use any more days, right, the smallest interval that we will create will exceed I of min, right? As I explained in this sample case, right? So this is essentially a proof by contradiction, okay? So now the question becomes this, right? Given an interval, right, length L, how do we, given an interval of length L, yeah, I already mentioned that here, how do we determine the number of days to create that interval? Right? And then, yes, we're using the variable L to define the interval length, right? So we can split it into, yeah, we have 3 disjoint test cases, okay? Disjoint. So the first is the edge case, right? So the interval could start at the first cow or ends at last cow, right? So in this case, the max number of days is going to be L minus 1, right? Because, you know, A, right? Like in the start at first cow case, right? Right. So for example, something like 1 1 0 0 0. Okay. We place the cow at index 0, right? First cow, and then the cow can only infect 1 cow to the right per day, right? So with that being said, if it only infects 1 cow to the left per day, and we already have 1 cow initially infected, to create any state in this case, it's simply going to be L minus 1, right? So we place cow at index 0. Cow can only infect 1 cow to the right per day, okay? What about B, right? So what about if our interval ends at last cow case, right? So what we're going to do, right, so in something like this, right, 0 0 0 1 1 1, right? We're going to place a cow at this last index, right? So place cow at last index. Cow can only infect 1 cow to the left per day. And with this rate, and we already have one cow initially infected, again, it's going to be L minus 1, right? So we figured out the edge case. Now let's go through our two main cases, which is going to be if that interval length is even and if it's odd, right? Okay. So in the case we have an even length, right? We need to note that we need an even number of cows to create an interval of even length, right? So this is because after D days, right, 2D cows will be infected, right? Now note that I'm saying that these test cases are disjoint. So when I'm talking about an even interval length, I'm talking about an even interval length that doesn't fall into this edge case, okay? So in this case, a cow can infect to the left and to the right. So that's 2 cows that it can infect per day. And you multiply that by D days, 2D cows are going to be infected, right? So the total, so thus, the total number of cows that are going to be infected is going to be what? It's going to be I plus 2D because initially we had I cows infected, right? And then after D days, 2D cows have been infected. So the total number of cows infected is I plus 2D, right? So I equals to initial number of initial cows infected, right? Now, in order for this quantity I plus 2D to be even, well, since 2D is even, then that obviously means that I has to be even too, right? So that's where we get this observation that we need an even number of initial cows, right? We want to figure out the maximum number of days to create this interval, right? So what we can do is we can say that we know that the interval length is going to be I plus 2D, right? So L equals to I plus 2D, right? Now we just need to solve for I. Now we just need to solve for D, right? So if we do some simple algebra, then this means, what does that mean? It's going to mean D equals to L minus I divided by 2, right? L minus I divided by 2. And then the smallest possible value for I is going to be 2, because that's the smallest even number, right? Okay. So it's going to be L minus 2 divided by 2. Okay. And this is because 2 is the smallest possible value for I, right? All right, even case done. Now let's go for odd length, right? So in the odd case, right, note that we need an odd number of cows to create an interval of odd length, as the total number of cows infected as L is going to equal to I plus 2D again, right? And in order for L to be odd, I must be odd, right? And remember, we have this correspondence where the smallest possible value for I is going to correspond to the maximum number of days again. So just like in the even case, right, the smallest possible value for I is going to be 1, right? Then we have L equals to 1 plus 2D, and that's going to mean what? D equals to L minus 1 over 2. All right, perfect. So we've done our case breakdown, right? Which means we essentially figured out the first step, right? So therefore, to figure out the maximum number of days to create the intervals, right, what we're going to just do is loop through all the intervals, and for each interval, figure out the maximum number of days to create that interval, and if it is smaller than our current answer, right, we update it. Boom. Step 1 done. Now let's move on to step 2, okay? So now that we have figured out D, we need to create a formula. We need to create that formula. We need to figure out init number of cows, this formula, right? So one observation we can make is this, right? So for each cow, including itself, it will after D days create an infection window of up to 1 plus 2D, right? Because the cow itself, that's where this 1 comes from, and then because for each day, it can infect either to the left or to the right at most, right? It's going to infect a maximum of 1 plus 2D. So therefore, for each interval, the minimum number of cows needed to create that interval is going to be given by, we take the ceiling, okay, of L divided by 2 by 1 plus 2D, right? So I'll explain the ceiling in a minute, but again, because each cow, the maximum area it can infect is 1 plus 2D, we get L divided by 1 plus 2D, right? And that's going to give us the initial number of cows if we add on top of that the ceiling function. Because we need to use the ceiling function. We need to use the ceiling function because to cover any interval, right, we need at least 1 cow, right? So in the case that 1 plus 2D exceeds L, right, it's not going to be 0 point something or 0, right? It's going to be 1. Every single interval is going to require at least 1 cow. So in the case that 1 plus 2D exceeds L, right, ceiling of L divided by 1 plus 2D, that's going to be equal to 1, right, which is going to satisfy that constraint. Okay, so with that observation, therefore, we just need to loop through each interval, apply that formula, and add that result to our answer. And we have solved the problem, right? So this is the algorithm, okay? So now let's code it up. Okay, so we're going to start out with setting up our I/O system. So we're going to create a new buffered reader, and then we're going to read from the input stream from standard system input. And then int n, we're going to get, that's going to be the first line, right? So integer.parseInt in.readLine. And then string the end state that we want is going to be the next line, right? So the first thing that we need to do is figure out what are all the intervals, right? So this is essentially the preliminary step, right? Let's see, I think we need to add a throws declaration, yeah. Perfect. So we're going to store that in a linked list. So list integer interval length equals to new linked list integer. Right, so int length equals to 0. And then we need to keep track of whether the first interval starts at the start and whether the last interval ends at end, because we need to analyze this edge case. So we'll have 2 flags for that. Boolean first interval is at start equals to false, and then Boolean last interval ends at end. That's going to be false, right? And then we just need to loop through all the intervals. So for n I equals to 0, I less than n, I plus plus, right? So if end state dot char at I is going to be 1, then that's part of an interval. And then first thing we need to check the edge case. So first interval is at start equals to true. And then we'll update the length accordingly. And then if it's a 0, right, then we're going to add that interval length to our list, right? If it is an interval, you know, the length has to be greater than 0. And then we're going to reset the length back to 0. in preparation for the next interval, okay? Now, there is sort of an edge case that we need to handle here, which is when the interval extends to the end, right, when it's, so if this is satisfied, so if this flag is true, then what that means is we also need to add that to our interval lengths list, but it's not going to be added with this code because this code is only going to get triggered if we encounter a 0 character, right? So we need to handle that. So handle the case where the interval extends to the end. So in this case, if length is greater than 0, right, then we're going to add the interval length to our list, and then we're going to set this flag to be true, right? Last interval ends at end equals to true, okay? Now we can go through, our procedure that we talked about. So step 1 is figure out the maximum number of days it takes to create each interval, right? So max num days to create intervals. We're going to initially initialize that to the maximum possible value for an integer. So we're going to loop through all of the intervals. We're going to get the interval length. Okay, and then handle the edge case, so interval starts at first or ends at last cal. So in this case, so if we're on the first interval, so if j equals to 0 and first interval is at start, or j equals to interval lengths dot size minus 1 and last interval ends at end. All right, then max num days to create intervals is going to be math.min, max number of days to create intervals, and then interval length minus 1, right? Typo there, okay. And then we have even length, right? So else if interval length divided by 2 equals to 0, then max num days to create intervals equals to math.min, max number of days to create intervals, and then our formula, what do we use for the formula? It's going to be, L minus 2 divided by 2. So it's going to be interval length minus 2 divided by 2. And then we have on length, so else max num days to create intervals. That is going to be math.min, math.min, max number of days to create intervals, and that's going to be, the formula is, L minus 1 divided by 2. So interval length minus 1 divided by 2. All right. So now that we figured out max number of days to create intervals, we can move on to the second step, which is to essentially derive our answer, right? So for each interval, figure out the minimum number of cows needed to create that interval from the maximum number of days. So step 2, figure out the min number of cows to create the intervals based on the max number of days to create those intervals, right? So int num cows equals to 0, that's going to be the answer that we're going to output. So we're going to loop through all the intervals. K plus plus. Okay, so the interval length is going to be interval lengths dot get k, and then we're going to apply that formula, which is, what did we say was the formula? It is ceiling length divided by 1 plus 2d. Okay, perfect. So num cows plus equals to math.ceil, interval length divided by 2.0 times max num days to create intervals plus 1. So we're putting 2.0 there to force the compiler to understand that we want double division rather than integer division, so we can seal it. And then finally, we're just going to output num cows, right? So that should be our solution. Let me see if we need anything else. Yeah, I forgot an import there. Okay, looks like we don't have any problems now. Let's submit the solution. Oh, before we submit the solution, yeah, before I forget, let's go over the time complexity and space complexity, right? So the time complexity is going to be what? It's going to be linear time, right? O of n, where n is the number of intervals. And we get that from just all the loops that we have, right? Where we just loop through all the intervals one by one, right? And the space complexity is going to be O(n) because we have to store each interval's length. So linear time and linear space complexity. Let's see if our solution works. And sure enough, it does. Passes all the test cases. So that is the solution. Feel free to like, comment, and subscribe, and I'll see you guys in the next one.